Hey Math Kids, today we're talking about logistic growth, and there's a lot of populations that kind of start off with an exponential curve, but then it flips and kind of levels out. And so that's what logistic growth is. Okay, on this we have an initial population on an island of 154, so we can write it like that. We also have expected growth of that population is defined by this function, and t is in years. So we're going to write p as a function of t. So what we need to do, we need to get all of the terms that have p in it onto the left with dp dt, and then we can use our differential equation methods that we've learned in previous videos to finish it. So what I'm going to do here, I'm going to write this as 500 over 500, the 1, and so that gives me 500 minus p over 500. Okay, multiply by the reciprocal. Let's see. We'll do dp dt 500. We'll write it different. Okay, so let's do 500 over 500 minus p times dp dt, which equals 0.16 p. We still have a p on the wrong side, so we divide by p. So I'm just going to write it in like that. Okay, and then from here, we're going to take the integral with respect to t. Both sides, those cancel. And so we're left with 1 over p times 500 minus p and 500 on top, dp, and 0.16 dt. Now, on this video, I'm not going to go through partial fractions again. If you need a refresher on how to do that, you can watch that video, but that's what happened right there. We just did partial fractions. Okay, and then if we take the antiderivative of that, we're going to get natural log of p, absolute value, and 1 over, not 1 over, natural log of 500 minus p, but then the reverse chain rule, we divide by the derivative of the inside, and so this ends up being a negative sign, because it's just -1. Okay, that's equal to 0.16 t plus c. And then we combine these with our exponent rules. And then we take e of both sides algebraically. We get, we do plus or minus. We'll get rid of the absolute value. Okay, now if we could rewrite this like that, and if we do that, then we can take this and this and make a, so plus or minus e to the c is equal to a, and we get p 500 minus p equals a e to the 0.16 t. Okay, your book approaches this a little bit different, but we're going to just take it to that. And let's get some room. Okay, now using this, we're going to figure out what a is. And so if we plug in 0 for t, actually maybe I don't want to do that yet. So I'll just do 154, I'll just rewrite it over here. So I plugged in those values. This all goes to 0, that all goes to 1, so a is just equal to this, which is going to be 154 over 346. Okay, so rewriting this, we get p over 500 minus p equals 154 over 346 e to the 0.16t. Okay, and then we just need to solve for p is our goal. And so what we're going to do, we're going to take this and we're going to think of it as let's see, we could do, it's actually going to be easier if I flip this upside down. So what I'm going to do is a little trick. I'm going to flip this upside down. So I need to flip this upside down and flip this upside down. So this negative will flip that. So I'll get 346 over 154 e to the negative 0.16t, because negative would bring it down to the bottom, and then 500 minus p over p. And now I understand why your book did that in the beginning. Now we can put each of those over p. So we can say 500 over p minus p over p. And that equals all this stuff. This is really just a 1, so we can add 1 over to this side. Okay. Now, what we're going to do is divide both sides by 500, or like multiply by 1 over 500. Let's cancel. So we have 1 over p equals 1 plus, I'm not going to read it, I will just write it. And then we just need to flip both sides to get p. So we have 500 over 1 plus 346 over 154 e to the negative 0.16t. Alright, so that was part A. Now, moving on to part B. Part B said find the population after 10 years. So conceptually that's very easy. We just plug in a 10 right here. And when we do that, let's go to calculator. So I'm going to do this e part first. So I'm going to say second e to the negative 0.16 times 10. Now I'm multiplying it by the fraction. I'm going to add 1. Alright, so that's the bottom of my fraction. So now I'm just going to go 500 divided by my previous answer. And we end up with 343.97. So if we round to the nearest person, that's 344 people. So after 10 years, there should be 344 people. Okay. Now, find the time taken for the population to increase to 480.